Alright guys, so this is 4.2, video number 2, so if you didn't watch the first one, make sure you watch that first. And on this slide in your notes, it just tells you some basic patterns for, I guess, some basic multiplication or powers. And these aren't something you necessarily need to memorize at this point, but as you do them, you're going to start seeing these patterns unfold, and it's going to become kind of routine. Okay, but we are going to learn Pascal's triangle now, and this is definitely something we need to tune in on. It's definitely something that you're either going to know it on the test or you're not. Okay, so Pascal's triangle is this right here. Okay, and we're not going to worry about what's left of this right now. Okay, and this keeps going on and on and on and on and on. Okay, now what this does is it gives us the coefficients of binomials raised to the, and I'm just going to put nth power. Okay, now you guys are looking at me thinking, oh my gosh, I have to memorize that. No, do not memorize this because there's a pattern that unfolds here. Okay, so first of all, I want you guys to recognize that the top row, we actually start at row 0. Okay, which makes this row 1, this row 2, this row 3, this row 4, and this row 5. Okay, and like I said, this keeps going and going and going. We can go all the way to infinity. Now, row O basically means that our n is 0. Row 1 means our n is 1. Row 2 means our n is 2, and so on and so forth. Okay, so anytime we have a plus b to the n power, regardless of what our n is, we can find the coefficients by working out this Pascal's triangle right here. Okay, now what I want you to notice is on the outsides, like this and here, these are all 1s. Okay, and that will always be the case. We can go down to the 1223rd row and it's still going to be 1s on the sides. Now, inside isn't so much. And it's not obvious what the pattern is, but if you look, okay, we're going to like straddle numbers as we go. Okay, so the two numbers that we're straddling, if we find the sum, 1 plus 1, that's going to equal 2. Okay, so that's how we could get the second row. Now the third row, we start with our 1 and our 1's on the outside. Well, 1 plus 2 is 3, and 2 plus 1 is 3. So row 3 would be 1, 3, 3, 1. Okay, now if I look at row 4, once again, we know we have 1's on the outside, and we just start at the top and work down. Now to find the numbers in between, the numbers that it straddles, so like this 4 is just 1 plus 3. The 6 is 3 plus 3. And then the 4 is the 3 plus 1. Okay, and then after that, we start with 1 and 1, okay, and then the 1 and 4 make 5, 4 plus 6 make 10, 6 plus 4 make 10, 4 plus 1 makes 5. Now, what I want you to do real quick is pause this video, and I want you to find the numbers for row 6, okay, so see if you can find the numbers for row 6. All right, so if we're going to find the numbers for row 6, we know it starts with a 1 and we know it ends with a 1. Okay, now 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. So this is what you should have gotten for row 6. Okay, now we're going to go on and learn how to apply this. Okay, now we can remember that Pascal's triangle gives us the coefficients of a binomial to the nth power. Okay, so something that looks like this. Okay, now if we look at this, my a is x, And my b, remember I want a plus b, so my b could be a -2. If you want to think of it as a plus -2, that's fine. And my n is a 5. Okay, so what I want to do is I want to write out the Pascal's triangle starting at the top, and I want to go to row 5. Okay, so I start with a 1, and then on the outside it's 1 and 1. Okay, and then I start on the outside, a 1. Now 1 plus 1 is 2, and then a 1 on the outside. Okay, so my next row is going to have 4 terms in it, so I start with a 1. 1 plus 2 is 3. 2 plus 1 is 3. And then a 1 on the outside. Okay, now I start with a 1 again. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then I end with a 1. Okay, I kind of lose track, so this is row 0, row 1, row 2, row 3. This is row 4, so I want one more row to be row 5. So I start and end with a 1, and 1 plus 4 is 5. 4 plus 6 is 10, 6 plus 4 is also 10, and 4 plus 1 is 5. So this is the row that I'm wanting. Okay? Okay, now I'm going to use these, and I'm going to expand this out without having to multiply all these out. Okay? So what I do is I take my coefficient, so my 1, and I'm going to do 1 to the a to the n, so I'll just write a to the n, okay, and then b to the 0 power, okay. Now, this n obviously is going to be 5 in this case, and we'll go and substitute that in, okay. Now, as I go with each successive term, the exponent of my a is going to decrease while the exponent of my b is going to increase, okay. So this would just be plus. Now the coefficient of my next term is 5, so it's going to be 5, and then my a to the n minus 1, I decrease by 1, b to the first. Okay, next, 10 is going to be my coefficient, so it's going to be 10, a to the n minus 2, and then b squared. Okay, I'm going to kind of write downwards, plus my next coefficient is 10 to the, or 10a to the n minus 3, and b cubed, plus my next coefficient is 5, a to the n minus 4, b to the 4th power, and then plus my 1, and that's going to be a to the n minus 5, b to the 5th. Okay, so basically, never mind. I'll go ahead and expand this out and you'll see. Okay, so if I plug this in, remember my a is x, my b is -2. So I can take this and I can say, all right, so here I have 1. Now my a to the n, my a is x, and my n is 5. So 1x to the 5th, and then my b is -2 to the 0 power. Okay, so there's that. Plus, now I'm going to do this one. I have my 5a to the n minus 1, so 5 minus 1 is 4. Or you can think about it, the value of x is going down. We are plugging in x for a now, my bad. And then we have -2 to the 1st power. Okay, plus, now I'm doing this one, 10. My a is now x to the n minus 2, so 5 minus 2 is 3, or we can just go 5, 4, 3, and then b, which is -2 squared. Okay, plus, now I'm doing this one, 10 x to the 2nd, -2 to the 3rd, plus, now I'm doing this one, 5 x to the 1st, and then -2 to the 4, plus 1, and then it's going to be x to the 0, and -2 to the 5th. Okay, now one thing that I want to go over is anything to the 0 power is going to be 1. Okay, if you don't know it, write it down. Okay, next thing I want to discuss is any negative number. If it's an even power, it turns into a positive. If it's an odd power, it stays negative. Okay, so if I go and I simplify this, well, this is just 1. I don't need to write 1. So 1, and this is a 1. So I'm left here with just a x to the 5th. Okay, plus 5, and I'm going to take baby steps here. X to the 4th, negative 2 to the 1st power is just a negative 2. Okay, plus, I'm doing this one here, 10 x to the 3rd, negative 2 times negative 2 is a positive 4. Plus 10, I have an x squared. Now negative 2 to the 3rd power is just negative 2 times negative 2, which is a positive 4, times another negative 2, which is negative 8. Okay, now I'm on to this one. Plus 5, just x to the 1st is just x. Negative 2 to the 4th would be a positive 16. And then plus a 1, x to the 0 is just 1. And negative 2 to the 5th would be a minus 32. Okay, now if I'm going to go and simplify this just a little bit more, this is just x to the 5th plus negative 2 times 5 is a minus 10 x to the 4th. Okay, 4 times 10 is plus 40 x to the 3rd. Negative 8 times 10 is minus 80 x squared. 16 times 5, let me get my calculator. 16 times 5 is 80 again, so 80x and then minus 32. Okay, so without having to multiply all these out, this is what you should get. All right, now we're going to work this out step by step. So the first thing I want you to do is I want you to draw out Pascal's triangle and know we're going to the 3rd power. So pause this and draw out Pascal's triangle and take it to the 3rd row. All right, you should have gotten this. Okay, now I just noticed this isn't here, so we are doing 3x plus 1 cubed. Okay, so now I want you to pause this and pull out your a, your b, and your n. Okay, so your a is always your first term, so it's 3x. Your b is your second term, which is 1, and your n is your power. So we have 3x, 1, and n. Okay, now's the hard part. I want you to try to take this and write it like we did here, this term right here. You don't have to plug in your a and your b yet, just write it out. So pause this and try that step. Okay, so you should have gotten this here. And most of you that'll make a mistake, this is where you'll make the mistake, so double check real close. Okay, and after you know you've gotten that right, then I want you to pause it again, and I want you to plug in your A and your B. Okay, and when you're done with that, you should have gotten to this. Okay, now from here I want you to simplify, but I want you to pay close attention to something that looks like this. Okay, remember, just a side note, 3x cubed is not 3x cubed. Okay, it's 3x quantity cubed, which means that this cube goes to both 3 and the x squared, so it's really 3 to the 3rd, x to the 3rd, which is 3 to the 3rd is 27, x to the 3rd. Okay, so as you simplify this, keep that in mind. Okay, now after you've simplified it, this is what you should have gotten here. Okay, now this is a little bit tougher, so I encourage you to do the monitoring progress, and I will make one more video just for that. If you're solid and you think this is easy, you don't have to watch it, but I do encourage you to do it because this is a little tougher to do on your own than it is, you know, when someone's trying to walk you through it.